Okay, section 14.1, Introduction to Rational Expressions. Let's just get through the definition here. Rational expressions. A rational expression is an algebraic expression that can be written in the form P over Q, where P and Q are polynomials and Q cannot equal 0. Let's just remember that a rational, let's just going to say this is fractions, expressions, that means just without equal signs. That's what that means. Introduction to fractions without equal signs. That's expressions. Remember, like an expression is just like, it would be like 2x plus 1, but there's no equal sign there. So, this right here, what does that mean? Remember, P divided by Q. P over Q. Q cannot equal 0, because if it does equal 0, it doesn't equal 0. It is undefined. I'll be asking you that a lot. Undefined. So let's continue on. Here's some examples of some rational expressions. We'll just kind of work through them real quick. Determine which of the values of the variable, if any, will make the rational expression undefined. That's what we're looking for. We want to find out, where is this thing going to be undefined at? Where is it going to equal 0? If it equals 0, it can't do that. So on this first one, let's look right here. This part right here cannot equal 0. So let's come over here and go 3x minus 1 cannot equal 0. Well, where? Well, let's add 1 to both sides. When we do that, we're going to get, there we go. We're going to end up getting 3x cannot equal 1. Divide off the 3. And for this one right here, x cannot equal 1/3. I don't know exactly how Hawks is going to want it yet. If you wanted to show this, that means x can equal anything else. So I could literally go from negative infinity up to 1/3, but not include it, and then go from 1/3 to positive infinity. That would be the domain of everything that this thing could equal. Simple as that. Let's go on to the next one. Going on here. Notice I'm not worried about the top part. I'm just worried about this. X cannot equal 0 here. Well, let's figure this out. I've got x squared plus 36 cannot equal 0. Come in here and I'm going to have negative 30, or subtract 36 and subtract 36. I end up getting x squared equals 36. I will take the square root of both sides. That I'll explain later. Well, here is the problem, and I've got a negative right here, and I'm sorry, there's a negative. Let's erase this just a little bit so that way it kind of makes sure. I want you to be able to see this really well here. There's a negative 36 right there. No. Can't have that. Not right now. So for this right here, you would literally have to put, if you come up with a negative inside of a root, this has no real solution. There is a solution. It's not real. It's a little above your pay grade right now. So don't worry. We will learn the rest of that later. Let's scroll down here. Let's finish up this last one here. Alrighty. This right here is just saying, wherever there's an A, put an A there. So I have 3 minus 3 all over 3 squared minus 5. Well, that's going to equal 0. And then 9 minus 5, which is going to equal 0 all over 4, which equals 0. This is doable. Okay, put it right here. Let's put it in. That. Okay, that is okay. Okay, you can have a 0 in the numerator, not in the denominator. So, summary arithmetic rules, can't read today, for the rational numbers or fractions. A fractional rational number is a number that can be written in the form a over b, it's just a fraction. Integers, counting numbers, and b cannot equal 0. Remember, no denominator can be 0. Fundamental principle, there you go, that's how you multiply. Reciprocal, flip it. Multiplication, multiply straight across. Division, flip the second term. Addition, find a common denominator. Subtraction, find a common denominator. Okay? Oh, well, look at that. That must be where my thing decided to draw a while ago. Okay. These are just here for you. You're going to see these plenty. I'm going to be working through a lot of examples. Okay? Just take a look at this. I'm leaving it here for you. So let's just go ahead and get on to some examples.